In this video, we are going to look at illustrative examples of the sum of arithmetic progression. Now, let's take a look at some of these examples. First, we have here, find the sum of the first 27 terms of the arithmetic progression, 8, 11, 14, and the sequence continue. So, from the given question, we know that the first term A is 8 and the common difference D would be 11 minus 8, which is 3, and the nth term is given to be 27. Now, you note that the sum of arithmetic progression is given by the expression n divided by 2, open bracket, into 2 of the first term plus n minus 1 times the common difference. Alright, so now we are looking at the sum of the first 27 terms. So this will give us is 27 equals to 27 divided by 2. The first term here is 8 plus 27 minus 1 times 3. So let's go ahead and simplify this. So this will give us 27 divided by 2, and 8 times 2 is 16, plus 27 minus 1 is 26. So we are going to have 26 times 3. Now, breaking this down, we are going to have 27 divided by 2, open bracket, this will be 16, plus 26 times 3 will give us 78. If you do that in your calculator, give us 78, and we know that this will be the sum of first 27 is 27 divided by 2, in the bracket. Now we had the 2, 16 plus 78, that will give us 94, right? So we have your 27 equals 2. So basically we can say that 2 is gone, and 94 divided by 2 will give us 47. So what we are left with is 27 times 47. So we can say that the sum of the first 27 of the given arithmetic progression is 27 times 47, which gives us 1269. Now let's also take a look at another question. The next question we have here is, an arithmetic series has first term 4 and common difference 1. Find the sum of the first 54 terms. So the first term has been given to be 4. The common difference D is 1. So we have to find the sum of the first 54 terms. N is given to be 54. Okay, so we know this is Sn equals to n divided by 2, 2a plus n minus 1 times d. So now we are looking at the first 54 terms. So this will be S of 54 equals to 54 divided by 2, and you open your parentheses. This will be 2 times the first term is 4 plus n, which is 54, minus 1 times d, which is 1. This is a common difference, times 1. Okay, now this is going to give us the first sum of the first 54 equals to, now 54 divided by 2 will give us 27. So this will be 27 exponent, and 4 times 2 is 8, plus 54 minus 1 will give us 53. So basically we are having 53 times 1. Okay, so moving on, this will be the sum of the first 54 terms equals to 27. In your bracket, this will be 8 plus 53. Okay, so we continue. This will be the sum of the 54 terms equals to 27, and this will be 8 plus 53. That will give us 61. So we can say that the sum of the first 54 terms of this given arithmetic progression is going to be 27 times 61, and that's gonna be 27 times 61. If you do this in your calculator, you are going to have 1647. 1647. Okay. Okay, so let's also take a look at another question here. The next question we have here is, find the sum of the arithmetic series with first term 1, common difference 3, and the last term is 100. So the first term is given to be 1, the common difference D is given to be 3, the last term L is going to be 100. Now you need to notice that we don't know the n term, so finding the sum of this arithmetic series, we need to find the n term. Now we also know that the last term is given to be the first term plus n minus 1 times the common difference D. So from here, our last term is 100 equals to the first term 1 plus n minus 1 times 3. So this will be 100 equals to 1 plus 3n, expanding this bracket. So what I did is to multiply 3 by n and multiply 3 by minus 1. So this will be minus 3. Okay, so let's go ahead and simplify those. This is going to be 3n minus 2. Minus 3 plus 1 will give us minus 2. So grouping like them, this will be 102. I send the negative 2 to the left hand side, which is going to give us positive. So that will be 100 plus 2, which is 102, and equals to 3n. Now let's divide through by 3, dividing both sides by 3. So we are going to have n equals to, this is gone, 3 is gone, so n is going to give us 34. 102 divided by 3 will give us 34. So let's see how we can find the sum of the given arithmetic series. Now we know that Sn is given to be the first term A plus last time, that is the partial sum of arithmetic progression, divided by 2 times the n. Okay, so that's the formula we are going to use, right? So now we are looking at the sum of the 34. So we are looking at the sum of the 34. So this will be S of 34 equals to, the first term is 1 plus the last term 100, all divided by 2 times the n, which is 34. All right, so this is going to give us the sum of the 34 terms equals to 101 divided by 2. So 1 plus 100 gives us 101 times 34. Now notice that 2 is gone, and 34 divided by 2, we are going to have 17. So this is going to give us the sum of the first 34 terms, give us 101 times 17. And if you punch this in your calculator, you are going to have 1734. So we can say that therefore the sum of the first 34 terms of this given sequence is 1734. The next section, we are going to look at finding the first term, the common difference, the end term when the sum of arithmetic progression is given.